Welcome to Paradox Lab. Our universe is a vast space with a scale beyond imagination. The estimated number of stars in the universe is greater than the number of grains of sand on all the beaches combined. This is a number that challenges the limits of human understanding. However, despite this, the universe is not actually as bustling as we think. In reality, the universe has an extremely low matter density. If each star were shrunk down to the size of a grain of sand, the average distance between each grain would be about 8 kilometers, roughly equivalent to the height of Mount Everest. On a real scale, that number is equivalent to 4 light years. This is a distance that humanity can never cross with what we currently possess. NASA's Parker Solar Probe, the fastest spacecraft humanity has ever built, would take about 7,000 years to travel this entire distance. And you should remember that this is only the distance from us to the nearest star. The nearest galaxy is hundreds of thousands of times farther than that. Faced with such unimaginable distances, humans seem to be locked in an invisible cage from which they cannot escape. All dreams of exploring the universe are limited by the laws of physics. It is as if the universe is trying to challenge humanity. Even so, we have not given up. Science and technology may be limited, but imagination is not. Based on physical theories combined with imagination, this ship has the ability to take us to the edge of the universe. This journey will certainly hold many interesting things. What will happen to us on such a journey? What is waiting for us at the end of the universe? All crew members are requested to get ready. The ship will take off in a few minutes. A journey to the end of the universe. First, I need to introduce our ship a little bit. This is a spacecraft that goes far beyond anything humans have ever built because it comes from imagination. The ship is capable of accelerating with an acceleration slightly greater than gravitational acceleration for an infinite amount of time. For those who do not know, gravitational acceleration is denoted by g and has a value of about 9.81 meters per second squared. A ship moving with a uniformly accelerated motion at 1g means that for every second that passes, its velocity will increase by 9.81 meters per second. In this case, our ship has an acceleration of 10 meters per second squared. After I finish this sentence, we will have spent 40 seconds since departure. Therefore, the current velocity has also reached 400 meters per second and will continue to increase. Let's set aside the technical issue of how a spacecraft can accelerate for an infinite amount of time. Let's just assume it can happen, at least in this video. Additionally, the ship possesses the ability to resist all types of radiation or any kind of collision along its path. At first, you might be a little nervous because you do not know what it feels like to be on a spaceship. This also depends on what kind of spaceship you are on. With our ship, everything seems relatively comfortable. Possessing an acceleration of approximately 1g, you will not experience floating in space like you often see in science fiction movies. The gravity inside the ship is equivalent to the gravity on Earth. All daily activities take place normally. A continuously accelerating ship may have a slow start, but over time, its speed accumulates greatly. After only about 2.5 hours, we will fly past the moon, and after a day and a half, Mars will be left behind. And guess what? Just 3 weeks after departure, we have traveled beyond the solar system. At this point, the ship is traveling at a speed of over 65 million kilometers per hour, which is about 6% of the speed of light in a vacuum. This speed is much faster than the Apollo 11 mission to the moon in the past, but it is still not fast enough for Einstein's theory of special relativity to take effect. Keep this information in mind because it is very important for the next part of the journey. As soon as we leave the solar system, we will head to the star closest to Earth in the universe. You can try searching for Alpha Centauri to learn more before we get there. The light from the star system is becoming clearer, while the sun has faded into just a tiny dot outside the window. For the next year, there will be almost nothing special. Time just passes by. The only thing that changes is our velocity, which continues to increase every day. Now, talking directly with your friends and family on Earth is impossible. This is because the time it takes for radio waves to travel back and forth is too long. However, your loneliness is somewhat alleviated because news, culture, sports, and scientific discoveries are continuously updated from Earth, albeit with a slight delay. It has been 15 months since the journey began, and our crew celebrates passing the distance of 1 light year. It is surprising, isn't it? But it is the truth. We are now a quarter of the way to Alpha Centauri, but in terms of time, we have completed a third of the journey. This is because the longer we travel, the more our speed increases. There is another important milestone we have passed. The Lorentz factor has now exceeded the number 2. Wait, what is the Lorentz factor? According to Wikipedia, the Lorentz factor is a term used to describe the curvature of space-time, which is directly proportional to the object's velocity. It is denoted by the letter Y. You can look at the screen for the specific calculation formula. In the formula above, Y is the Lorentz factor, V is the velocity of the object, and C is the constant speed of light. This factor leads to the direct consequence of the theory of special relativity. What I just mentioned describes that as the velocity approaches the speed of light, an observer watching the object's motion will see the object become shorter, and time inside the spaceship will also pass slower than the observer's time. For example, in this case, the time since the ship's departure for people on Earth is 15 months. But for our crew members, it does not feel that long. Einstein's theory of special relativity is truly having a very clear effect on the ship and the crew. According to observations, we are moving away from Earth at 87% of the speed of light. If nothing changes, the observed speed of the ship will exceed the speed of light in the next 45 days. But according to Einstein's theory, which has been rigorously tested and proven, nothing can travel faster than light. Furthermore, all observers will only be able to see objects moving at a maximum of the speed of light. This begins to lead us to confusing physical phenomena. Why can nothing be faster than light? Suppose you are driving a car to chase another car in front of you. You will see the other car appear to be running slower than its actual speed. If the other car is going 100 km/h and you are driving at 90 km/h, it will pull away from you at a speed of 10 km/h. But if the object in front of you is a beam of light, it will pull away from you at a constant speed. The speed of light, about 300,000 kilometers per second, is fixed and completely independent of the motion of the observer or the light source. So when the speed of light is a constant, time and space must change. How much they change is expressed through the Lorentz factor. That is exactly what is happening to our ship. Observers on Earth seem to see the crew taking more time to reach the destination compared to what we feel. Not only that, when the Lorentz factor exceeds the number 2, it also affects the perception of the ship's acceleration rate from the perspective of Earth. Observers from Earth will see that we are no longer accelerating at 1 g, but it gets smaller and smaller until it reaches the speed of light. Therefore, saying nothing can be faster than light is from the observer's perspective. But of course, for you and the crew, nothing has changed. The ship continues to accelerate infinitely, and in fact, it surpassed the speed of light a long time ago. You can feel this more clearly when you look out the window. The light of the sun fades much faster than you think. Figuratively speaking, the closer we get to the speed of light, the more we separate from the rest of space-time. But accelerating forever is not a good idea. We do not have an endless source of energy for this. At some point, you will need to slow down, stop, and land to step outside and explore your destination. This process also requires a massive amount of energy, which is hard to meet. Therefore, we can calculate to decelerate the ship with an acceleration of -1g. This means that every second, the ship will decrease its velocity by 10 meters per second until it completely stops. To achieve that, we will start the deceleration process right after the journey has completed half the distance. Returning to the initial journey, we have arrived at Alpha Centauri, which is 445 light-years away. If a beam of light originated from Earth, it would take 4.4 years to get here. But the time on the ship has only been 3.5 years. You do not need to worry about the ship violating the theory of relativity, because, for an observer on Earth, the actual journey has taken 6 years since the starting day. You can comfortably spend a few weeks exploring this new planet, then board the ship and return. The return journey also unfolds similarly to the outbound trip. Accelerate at 1g to the halfway point, and then gradually decelerate at -1g until returning to Earth. When you get home, about 7 years will have passed for you, but for everyone on Earth, it will have been 12 years. Not a bad amount of time to set foot on the nearest star. All right? Now I want you to pay closer attention to the detail that the ship decelerated every time it reached half of the journey. That point was 2.2 light-years away from Earth and occurred 8 years after the movement began for the crew. The velocity at that moment was 95% of the speed of light for an observer. A heated debate broke out among the members, with 2 different streams of opinion. Ultimately, everyone agreed that we no longer want to land on Alpha Centauri. We will use this ship to advance further into the universe. A typical journey is divided into 4 phases, including outbound acceleration, outbound deceleration, then return acceleration, and return deceleration. The next milestone we want to pass is about 30 light-years, escaping the boundaries of the local interstellar cloud, where the solar system resides. To make this trip, we will spend 4 years on the ship for both the outbound and return legs. But when we return, our children will have aged by nearly 70 years. This leads to bizarre reunions like you see in the movie Interstellar. Of course, we do not just stop at 30 light-years. Upon crossing that boundary, the next thing we face is a local bubble, originally named the local bubble. Spanning over a diameter of more than 300 light-years, it will take us 22 years of ship time to complete a round trip. But by the end of the journey, Earth will have experienced 600 long years. It will probably be very hard for us to adapt to the changes of the world. How many people will remember that 600 years ago, a crew left the planet to head out into the vast universe? 22 years is a relatively long time. However, we will probably still be quite young. If the crew wants to dedicate more to this mission, we can even consider leaving this galactic spiral arm, the Orion arm. Do not think that it is too far-fetched. Remember, the ship we are traveling on can accelerate continuously. So it only takes about 31 years on the ship for the round trip to the edge of Orion and back. Those 41 years are still a journey with 4 stages. We will reach maximum speed in the 8th year and end the outbound acceleration phase. However, after 6.5 years of acceleration time on the ship, when looking out the window, you will see something very strange. Some glowing red object is appearing and getting larger and larger. At first, you might think you are experiencing an illusion, or maybe your eyes have a problem. But then you realize that our current Lorentz factor has reached 650. As a result, the cosmic microwave background radiation is gradually shifting into visible red light waves. In the final year of the outbound acceleration phase, we see this glowing red space becoming stronger until reaching maximum speed. It is as if the ship has attracted the attention of the universe itself. Going further than the spiral arm to reach the edge of the galaxy is also not a bad idea. Over 100,000 light-years, that unimaginable number will be completed after more than 20 years for the outbound phase. With 41 years in a round trip to the edge of the galaxy, we will be over 60 years old when we return. As for Earth, it will have witnessed millions of years pass by. Can you imagine how humans will change after 1 million years? This world will probably be very different. We can refer to the ideas about the future world from scientists at the Ames Research Center of the American Space Agency to make it easier to imagine. First of all, after 1 million years, Earth likely will no longer provide enough living space for humans. Therefore, large space stations in orbit are a fairly perfect choice. There are 3 potential design models for future space stations, including the Bernal sphere, the toroidal settlement, and the cylindrical settlement. The capacity of these space stations ranges from 10,000 to 1 million people. They are capable of rotating to create artificial gravity. The cylindrical settlement, the most spacious among the ideas, features large windows that allow sunlight to shine down on the landscape inside. This design is also known as an O'Neill cylinder. Residents live on a curved surface similar to a glass palace, and they can cultivate agriculture there. Light reflects through windows near the poles. To solve the radiation problem, researchers use lead polyethylene shields or electromagnetic fields similar to how Earth's magnetic field protects us from space radiation. Generating oxygen in space is currently done through the electrolysis of water. NASA has also developed technology capable of absorbing CO2 gas, an abundant source on planets like Mars, and converting it into oxygen and carbon. Certain caves on the Moon with a comfortable temperature of 17 degrees Celsius could also be used as settlements. Most recently, scientists at Bangor University in the UK have developed an energy source that could allow astronauts to live for a long time on the Moon. The energy source is said to be a nuclear fuel cell measuring 12 by 18 centimeters, providing power to a micronuclear generator. This research could make space travel safer and more efficient. At the same time, it opens the path for ensuring energy security for life in outer space. With a span of 1 million years, it is highly likely that the aforementioned technologies will be perfected to the maximum extent, ensuring humans the most comfortable life possible. By the time we return, it is likely that many things will surpass our imagination. Plans to establish life in outer space or on some neighboring planets have already begun right now. NASA is using 3D printing technology to find a way to build houses on the Moon by 2040. The materials are made from lunar dust, and ordinary people can also live in these houses. In 2022, NASA executed the first mission in its Moon project. The spacecraft orbited the Moon and safely returned to Earth. The Artemis II mission will carry real people, consisting of 4 crew members, on a 10-day flight around the Moon. It is scheduled to take place in November 2024. The Artemis III mission will take place in 2025. At that point, humans will land on the Moon. However, due to certain difficulties, the mission has been delayed compared to its expected time frame. The Moon is still not humanity's final destination according to NASA's plan, but merely a rest stop and refueling station on the way to Mars. NASA is currently implementing a program testing living in an environment with conditions similar to Mars in the U.S. state of Texas. 4 volunteers acting as NASA astronauts have been conducting this experiment for a period of 1 year starting from June of this year. Meanwhile, SpaceX, the company owned by billionaire Elon Musk, is building plans for humans to go directly to Mars to settle. Anyway, this is all just hypothetical. and there are countless possibilities for the world after a 1 million year journey that we cannot fully predict. The new era inhabitants of Earth might use completely different languages from the ones we know today, and the logbook of our ship's journey will become a precious ancient document representing a brilliant civilization from the past. Being over 60 years old might be the limit for some members. However, there will certainly be those luckier than that, with an additional 15 years, meaning 56 years on the ship. We could make a trip to another galaxy, the Andromeda Galaxy, and return to Earth. We would lose some teammates, but we would have witnessed another galaxy with our own eyes. 5 million years on Earth will have passed. We might be the last remaining remnants of humanity if something unfortunate happens. Even if humans are no longer around, the planet seems even more beautiful than the day we departed. Biodiversity has almost recovered to pre-human levels. Coral reefs stretch across all the oceans. The suffocating cities disappear as nature reclaims the places it originally belonged to. If we want to travel further than Andromeda, we must consider methods to extend lifespan. Here, I can suggest a few options for us to reference together. Scientists from the Mayo Clinic College of Medicine and Science found a way to increase the lifespan of mice by 35% without leaving too many side effects. If this ratio remains the same, the average human lifespan worldwide will reach 95 instead of 71 as it is currently. Specifically, the secret of this technology is the removal of senescent cells that can no longer divide. Additionally, this scientific method delays the onset of age-related diseases such as cardiovascular disorders, kidney failure, and cataracts. In fact, aging cells appear everywhere in the body over time, including the skin, muscles, and internal organs. When subjected to too much stress, these cells also stop dividing. Generally speaking, cellular senescence is a biological mechanism that functions as an emergency brake to stop cell division, and it is frequently utilized by damaged cells. Although preventing cell division limits the risk of developing cancer, these cells become redundant if the emergency brake mechanism is activated. Furthermore, the immune system regularly removes damaged cells from the body when a person is young. Over time, this function becomes less efficient. Damaged cells simply accumulate gradually inside the organs and devastate the body as we age. More notably, these are all cells associated with dangerous conditions such as heart failure, arthritis, Alzheimer's, and cancer, with the goal of keeping the body's removal of damaged cells functioning well in old age. Researchers induced genetic mutations in laboratory mice so that they continue to produce caspase, a protein that plays a crucial role in the body, by eliminating damaged cells. This protein only appears in response to another protein, named P16, which is produced by frail cells. The process of producing caspase was regulated by scientists using a special drug, and middle-aged mice were injected twice a week throughout their lifespans. Afterwards, the scientists discovered that the older the mice became, the more effective this method was. Specifically, the lifespan of the mice was extended by 17 to 35%, while they also remained healthier compared to other old mice that did not receive the drug treatment. However, this therapy is still not perfect. Some senescent cells have not been removed at all, including those in the intestines and liver, thus causing hard-to-control damage. Currently, researchers have set a future goal of finding a way to completely eliminate senescent cells from the human body. This is definitely a much more difficult task than conducting it on mice. The ultimate result of this research process is the need to develop a drug with similar efficacy for humans, hoping to eliminate about 60 to 70% of the frail, aging cells in middle age. This research has attracted the attention of quite a few investors. The company Unity Biotechnology has become the first investor for the scientists developing the anti-aging drug. The dream of living to 100 years old is becoming increasingly practical. With new life-extending technology, we can undertake a journey beyond the Virgo galaxy cluster, where we currently reside. This journey is expected to last 67 years round trip. The Virgo galaxy cluster is located within the Lake Supercluster, a region of space spanning millions of light years and containing tens of thousands of other galaxies. To transcend this space, you need a 76-year round trip. At maximum speed during our journey, our Lorentz factor is around 250 million. And of course, all these destinations fall within an acceptable time frame for life extension technology that removes aging cells. I cannot calculate how massive the time difference has become when we return to Earth. The change is clearly visible from outer space. The continents have shifted and are no longer in their old positions. There are no plants left, nor are there any animals. We cannot even breathe normally like we did when we left. During this time gap, the sun's brightness has increased by nearly 10%. This facilitates a horrifying rate of weathering on Earth. The amount of CO2 has decreased to a level where plants can no longer photosynthesize, and without plants, there would undoubtedly be no life. If lucky, perhaps we might still find a few simple microorganisms that can survive. Earth is truly taking its last breaths. On this return, we will surely feel deep sorrow for our homeland, which was once glorious in the past. So there is only one way left to forget that sorrow, and that is to never return. Laniakea is not the end of the universe. We can go even further. After all, time dilation is now so significant that we can travel exponentially farther distances with each passing year. By using a ship with an acceleration of 1g, could we reach the edge of the observable universe? Unfortunately, the answer is no. When distances are measured in billions of light years, the expansion of the universe distinctly affects our journey. In 1998, astronomers used telescopes to observe distant supernovas in order to study the universe's expansion rate. It is accelerating every day, as seen in the descriptive images we are shown. No one understands why this is happening. Some suggest it comes from dark energy. Using various speed measurements, we can determine different limits within the universe. For example, the particle horizon is the maximum distance a particle of light could have traveled since the Big Bang occurred about 13.8 billion years ago. According to common understanding, it would travel about 8 billion light years. But in reality, due to cosmic expansion, that distance is actually much greater, reaching up to 46 billion light years. Now returning to our ship, if we want to make a round trip over distances of billions of light years, expansion causes the distances between regions to gradually increase. This means we would have to travel increasingly further. If moving within a region affected by gravity, like a galaxy or a supercluster, this does not happen because gravity counters the expansion. However, once we transcend the supercluster, nothing protects us from cosmic expansion anymore. With a terrifying formula, as you can see, the final figure produced is 8.3 billion light years. That's right. This is the final boundary we can reach if we still want to return. Beyond this number, we are permanently trapped by the void simply because the universe's expansion speed is many times greater than the speed of light, the final move on the chessboard of destiny. Do you want to return or not? What happens if we decide this is a one-way trip and we never return? What is waiting beyond that 8.3 billion light years? The current answer is nothing. The spaceship is no longer a distance-traveling vessel, but transforms into a time machine. With 200 years of continuous acceleration measured in ship time, time on Earth will have passed by 10 to the power of 41 years. This time is enough so that even protons, theoretically, could decay and dissolve into nothingness. And finally, I can tell you that this journey has ended. We have reached the very end, where there is no longer time or space. However, keep in mind that no conclusion is entirely accurate at all times. Even science is constantly changing day by day. A few centuries ago, people still thought the Earth was flat, and the Sun and other celestial bodies revolved around us. Who knows? In the future, with just a few scientific advancements, the universe might not remain as mysterious as we think. So we have just completed a special journey. The question now is, if everything ultimately heads towards nothingness, should we expend our mental and physical energy exploring the universe? Does that ultimately have any meaning? This answer will perhaps have to be left to the researchers, because only they truly know what they are doing. Personally, I think humanity may never achieve the journey we imagine today. But one thing is certain: humans will always have enough ambition to push civilization further. To accomplish this, space exploration must be strongly promoted. Due to limited time, today's video will end here. Thank you all for your interest and attention. Goodbye, and see you in the next videos. Wishing everyone a good day with your family.